Hi everyone, we're going to find the solution set for each polynomial. These are inequalities. This is part 3 and they get a little more complicated as we go along. So these are the 3 problems we're going to be doing, and I highly suggest you watch part 1 and 2 first. So the first one is going to be x minus 1 times x squared plus x plus 1 is positive. So this is your function. It's already been factored for us. Just copying this down. Alright, that's your function, your f. And this part right here has no real solutions. I do have a video on using the discriminant to determine if there are any real solutions. We're only looking for real solutions. So the only real solution I have is x equals 1. That just means x is 1 when y is 0. Okay, so when we set our table, when we have x equals 1, our intervals we want to choose are from negative infinity to 1, and then 1 to infinity. We want to see what's happening on either side of the 1 for the graph. And so when you choose numbers, I'm going to choose 0 for this one and 2 for this, and we're going to plug it in to our whole equation. And you can just plug it into this one. We don't need to distribute this out. So the value, when you plug in 0, you get negative 1. And when you plug in 2, we get 7. This is a negative number. This is a positive number. So basically, we want positive. So we only want this interval here. So our solution set is x such that x is greater than 1. Okay, the next one we had was, let me get over here. We have 3 solutions basically. So it's x minus 1 times x minus 2 times x minus 3 is negative. And you're going to go ahead and set your function. I really don't want to FOIL this one out either, so I'm just going to leave it like this. And find our zeros for each piece. The 0 to this one is 1. The 0 to this one is 2. And the 0 to this one is 3. Basically, these are your x-intercepts. Alright, and those are the zeros of f. So we're going to use all of those for our intervals. Again, our zeros were 1, 2, and 3. So I'm going to go negative infinity to 1. Then I'm going to go 1 to 2. Then 2 to 3. We're trying to see what happens on either side of the graph. And 3 to infinity on each piece of this. Now choose your numbers. So I'm going to, on this one, choose 0. This I'll choose 1.5, 2.5, and I'll go ahead and choose 4 here. You can use your calculator, and you just plug them in. We get negative 6 here. We get 0.375 here. Negative 0.375 and 6. And basically, we don't really care about those numbers. We just care if they're negative. This is negative. This is positive. This is negative. And this is positive. And our equation is we want it to be negative. So we want our f of x to be negative. So we're picking this interval and this one. Those are two negatives. So you're going to write your solution set is x such that x is less than 1. Then we have this one, so we write or x is in between 2 and 3. Okay, the last one we have, is this one. X cubed minus 2x squared minus 3x is greater than or equal to 0. Now, I'm going to go ahead and that would be our f as well. I'm going to go ahead and factor out an x. So we get x squared minus 2x minus 3. And then I'm going to factor this piece. So that would be x plus 1, x minus 3 is greater than or equal to 0. Now our zeros, we have a 0 here at 0. This is like x minus 0. So we have a 0 at 0, at negative 1, and at 3. That would be x equals those. Or you could write 0, 0, negative 1, 0, and 3, 0. Basically, those are your x-intercepts. Those are your zeros. Okay, so we're going to use all of those for our interval. And we're going to use, let's see, negative infinity, because we had negative 1, 0. I put these in order. These are your zeros. So you put them from smallest to biggest. Then we have negative 1 to 0, 0 to 3, and 3 to infinity. All right, we're going to choose numbers. So the numbers I chose were negative 2, negative 1/2, 1, and 4. And we're plugging it in to f of x equals x squared minus 2x squared minus 3x. And again, we want this to be positive. So when you plug in negative 2, you get negative 10. Negative 1/2 is going to be 0.875. Negative 4. And then 20. We want the positive numbers. Well, this one's negative, positive, negative, positive. So we want the positive. So this would be the positive, and this would be the positive. So our solution set is x. And for this one, we have x is in between, and we can put equal now because we have an equal here. Negative 1 and 0, or x is greater than or equal to 3. And that's all. Thank you. Have a nice day. Bye-bye.